I welcome all the students. Today we are going to learn the demonstration of 2D translation. In the last session, we have learned the theoretically how this two translation work, what is this matrix, and the related diagrams. Today we are going to learn how we can implement the 2D translation in C program or with the help of the C program. Again, save the time. See, instead of typing the complete program, okay, so I have written the program as per the algorithm of the 2D translation. So I'm just opening the program now. In the comment, I'm going to write down what is the name of the program is. Program for implementation of 2D translation. Okay, we are going to learn the program, okay, for implementation of two-dimensional translation. Okay, so under 2D transformation, the first basic type of the transformation is known as translation, where we are going to move the object, or where we are going to shift the object or translate the object in x and y direction. Okay, so as usual, we have included hash include stdio.h, conio.h. Okay, so we are including the maths.h. Okay, so if we require some mathematical function, okay, so that's why we have included this maths.h. Okay, and then we are going to include the graphics.h, okay, because this graphics.h uses the graphical function. Okay, so it is I need to initiate the graphics mode, okay, and start the graphics mode with the help of the graphics.h header file. Now, whenever we are going to translate the point, okay, or maybe we are going to rotate the point, okay, and scale the point, we may require some in the type of the multiplication, okay, in the form of, we can say, addition. We may require the floating value, okay, in some of the cases. So by take just to take the due care of this, okay, I have defined these values as a float. Okay, now in this particular program, I call this program is a generalized program. Okay, the program takes the input of number of vertices to draw the object. Okay, so I just write it in the comment here. Okay, takes values of vertices and draw the polygon. Okay, so we are allowing, okay, so it takes the values, okay, means obviously values in this case it will be x comma y values. Okay, so it is going to take the values of x of and y of vertices and draw the polygon. Okay, so in this case, suppose user want to draw the triangle, it will enter the number of vertices as 3. Okay, if the user want to draw the rectangle, it will enter the number of vertices to be 4. Okay, if it want any other shape, okay, then it will depends on number of vertices it is going to enter and the respective values are entered by the user. Okay, now for this particular purpose, okay, so we have used this variable vx and vy. Okay, so this vx indicate the number of vertices, okay, and its respective x value, and v indicate again number of vertices v and in y direction. Okay, so we have considered that maximum 10 vertices are there. We may increase the size of this particular array. So these vertices store the values of original object. Okay, now in some of the program it is necessary that after transformation, after applying the translation, scaling or rotation, I think the original value should not change. Okay, so that is the reason we are having the another array tvx. Here the t indicate transformed object. Okay, after the transformation object, what should be the values of the x and y? Okay, vertex x and vertex y. So we are having t vx and t vy. Okay, so this is for transform object. Okay, so these are the two, means in vx and vy, the array vx and vy, we are going to store the values of original object, and in the tvx and tvy, okay, array, we are going to store the values of x and y after transformation. Okay, once the object is transformed, okay, so after transformation, we are going to store these values in this, so that my original values will remain as it is. Okay, so as you are knowing, the next variable that we have declared is xc and yc, because I'm going to divide my screen into the four quadrants. Okay, so this 320. Okay, so and 240 is the center of my screen. Okay, considering the resolution of 640, okay, 640 by 2 I get 320, and 480 by 2 I get 240. Okay, so this is the value that we have declared. Okay, here we have taken the variable nv to indicate number of vertices. Okay, because we are going to take this input from the user will enter number of vertices. Okay, if it is enter 3, it may want to draw the triangle. If it is 4, it may want to draw the rectangle. Okay, so nv indicate number of vertices. I is used for the for loop. Okay, so these are the variables that we are having. Okay, now to minimize the work, to have a easy understanding of the work, okay, we are using one function, okay, which is going to just, its task is to draw the original object, okay, to display the original object. So I am writing it here. Okay, used to draw the original object. Now this draw original object, or this draw original function, okay, so now we are using one function called as draw original, because from the main function I can call this draw original, and I will show the original object. Okay, so now for this particular purpose, okay, what we are having is, we are going to clear the device, clear the screen, then we are going to set the color 15, because the original object color is white, 15 indicate white. Okay, so we are having set color 15. Okay, I write it here. Original object is of white color, WHITE. Okay, and its value is 15. Okay, so I set the color to 15. Then I am going to divide my screen into the four quadrant. Okay, as we have learned this also into the Breslham's algorithm and all other algorithms. So I am drawing these two lines to divide the screen, horizontal line, vertical line, and divide the screen into four quadrants. Okay, now after this, okay, this is the for loop that we are using to draw the original object. Okay, now while drawing this original object, if you concentrate on the for loop, my for loop I'm having is for I is equal to 1, I less than nv and I plus plus. Okay, so this nv indicate the number of vertices I'm having. So in the for loop, I'm going to connect the line number 1 to, or line number A to B, B to C, and so on, and C to D. Suppose I'm having 4 vertices, I will draw the line. So this line, okay, that I'm going to have is, this is the, so why we are adding this xc plus, okay, because just to shift the line to the, as I have divided screen to 4 quadrants. So actually my line will be Vx of I and Vy of I. Okay, 2. What will be my next point? My next point is Vx of I plus 1. Okay, and my next point is Vy of I plus 1. So I'm just connecting the value from x of I, comma y of I, to x of I plus 1 and y plus 1. Okay, so in this way we are going to draw it. Okay, but now after this for loop, okay, we are having this particular line also, separate line function is there, because after connecting all the lines, I think one more line that we have to connect, that is the last point should be connected to the first point, or we have to connect first and last point. Okay, so I write it here in comment. Okay, draw first, okay, or line from, rather I write it as line from first to last point. So, or last vertices, what we can say in this particular case is, okay, so we are going to draw a separate line, because this should not be in the for loop. Okay, in the for loop, if I just add this, it may connect some garbage value. So what I'm going to do here is, now this line is going to connect the first point. What is my first point? I have considered here x1, vx of 1. X of 1 is first point, and x of nv, because nv indicate number of vertices. So I'm having the 4 vertices, then I'm going to connect the first and fourth point, okay, to complete that particular polygon or to completely draw the object. Okay, so this draw original function, okay, this completely function is used to draw the original object. Okay, now similarly, okay, as we have drawing the original object, okay, I'm using the one more function, okay, to draw the transform object. Draw the transform object. Okay, now to draw the transform object, the name of function I have used draw t for transform object. Okay, so now if I want to show the color of transform object should be different than the original color. So original object is having the color white, so the draw after transformation, I'm just changing the color of the object to understand it is a transform object. So I set the color to the yellow, and again I'm using this for loop to draw the transform object. Now what is the only difference is here I am taking the value as t vx of I and t vy of I. Okay, t indicate transform vertex x value. Okay, and in original object we have taken only x vx, okay, vertex x value, and here t vx, here t stands for after transformation. Okay, that is the change value. Okay, so similarly we are using the for loop to draw this line. Okay, and the last line was separate function outside the for loop to connect the last and first point. Okay, so this is the function that we are using to draw the transform object. Okay, so let us move to the main function now. Understand the main function. We have declared the graphics driver GD and GM as usual. Okay, GD indicate graphics driver and graphics mode. Okay, and this is used in the init graph function to initialize the graphics mode. Okay, now here we are using one more variable, that is tx and ty. Okay, so this tx and ty indicate the translation factors. Okay, so user want to translate the object or want to move the object in x direction by value tx. Tx stands for translation x factor, translation factor x, and ty indicate this translation factor in y direction. Okay, so tx and ty that we have used as a translation factor. Obviously we have to take this input value from the user. Okay, so now after initialization of the graphics, okay, what is my first step is I'm going to take the input object. Okay, I have to draw the object first. Okay, my step number 1 to draw the object. Okay, how I'm going to draw the object? I say it is a generalized program because I'm not drawing only the triangle. I can draw any object by taking the number of vertices. Okay, so we are taking here, enter the number of vertices. Okay, so I take scanf and that value is stored in NV. So NV indicate number of vertices. Then I'm using the for loop, okay, to take the values of all these vertices. To enter the first point of object, then we are going to enter the second point of the object, and so on. Okay, so all these values where we are going to store, we are storing into the vx of I and vy of I. Okay, so I'm not this why we are using the number of vertices, because the user can draw any object. If it will give only 2 vertices, it will want to draw the line. If it is 3 vertices, it may be triangle. If 4 vertices, it may be rectangle, and so on. Okay, so we are using the generalized program where user can enter the number of vertices and draw the object. Okay, now once we are taking the number of vertices and their values as the input, okay, what we are going to call? We are going to call the function draw original. Okay, so we are going to call the function draw original. So the original object will be drawn, and I can visualize, yes, this is my object which I want to translate. Okay, that is displayed on the screen. Now after that we are using the clear device, because I just clear the device and now I am going to take the input as a translation factor. Okay, so these are my translation factor, enter translation factor tx and ty. So I'm going to take these values of percentage d, percent tx and ty as the input from the user. Okay, so here we are going to take translation factors tx and ty as input from user. Okay, so here user will decide that I want to translate my object how many points or how many values in the x direction, so that is my tx, and also into the y direction. So I'm going to take the values of tx and ty. Okay, now after that, okay, so I call it as, here I'm going to apply the translation. Okay, so I'm going to apply the translation here. Okay, now as all of you are doing in the translation, what we are going to do, we are going to just move the object into the x and y direction. Okay, so my formula is very simple, that is my transform x. This is nothing but you can call it as theoretically x dash value. Okay, t vx of I means you can consider as x dash. X dash is equal to vx of I plus tx. Okay, so I just consider here, if I'm considering it as x and dash, okay, x dash is equal to x plus tx. Okay, because now here x dash means transform object. After transform, I think we have used this for loop and the name of variable as tvx. So tvx is equal to, vx is my original x, okay, plus tx. Okay, so similarly, okay, so as per our formula, what we are going to apply is, we are going to use y dash, okay, is equal to y plus ty. Okay, and how many times it is applicable? It is applicable to all the points of the vertices. So I is equal to 1, I less than or equal to nv. Now why it is less than or equal to nv in the for loop? Because we have started I value is equal to 1, not as a 0. Okay, so if it is 0, I think I move from 0 to, and the condition is I less than, okay, not equal to, but here I am starting with I is equal to 1. I consider I equal to 1 indicate my first vertex, okay, or first point of the object. Okay, so this is used to apply the translation, and again I'm drawing the original object, and again I'm going to, after the original object, I'm going to draw the transform object, okay, to see the change, whether the object is translated appropriately or not. Getting me? So this is what the program that we have used for the to implement. This is the program that we have used to implement of the 2D translation. Okay, now I just execute the program to see the output. Okay, F2 to save the program, F9. Okay, it is not having the errors or warning, and then I use Control F9 to execute the program. Okay, now the first thing question it asks, number of vertices. Okay, suppose I want to draw a triangle. Okay, so I will enter number of vertices will be 3. Consider as theoretically we are having the triangle with 3 points, that A, B and C. Suppose my A point or first point is having the value 100, 100. So X and Y both values are 100, 100. See, I want to draw from A to B, okay, as a horizontal line. So my X value changes. So suppose my second point is 200 and 100. Okay, and third point is in between these A and B. Okay, so my X value will be 150 and Y value also increases. So I suppose take 150, 150. Okay, so here the A point is 100, 100, B point is 200, 100, and C point is 150, 150. Okay, so these are the, I want to draw the triangle, so I given the number of vertices as a 3. Okay, so I press enter to check my object is correct. Yes, you can find on the screen the triangle is drawn and it is having the values as we have given. Okay, so my first point A is 100, 100, second point B is 200, 100, and my center point C, okay, is having 150, 150. Okay, I hope it is clear. Okay, now what we have to do is, okay, we have to enter the translation factor tx and ty value. Okay, so I have to enter that. I want to move the object in x direction and y direction with what value. Okay, now suppose I want to move the object, okay, in x direction by 50, getting me, in x direction by 50 values, and in y direction by 10, means by 50 point or 50 scale I want to move into the x direction, and by 10 I want to move into the y direction. Getting me? So if I press enter, okay, I will get this my original object drawn with the white color, and if I press enter again, you can find this is the translated object. Okay, you can find that the object is moved by 50 points in x direction and only 10 points in the y direction. So y movement is only 10 and x movement is, you can find it as 50 value. Okay, so this is my program which showing the correct output. Okay, my object is translated. See, as we have divided the screen into the 4 quadrant, what was our purpose is I can draw the object in any quadrant and I can move it into the any quadrant because it is my translation. I just going to move the values in x and y direction. Okay, so now let us have the example. Now I want to draw my triangle into the second quadrant. Okay, second quadrant means where the values of x are negative. Okay, so I just draw the object. I am going to execute the program. This is my second example for you to show. Okay, so I'm just going to execute the program again. Okay, F2 to save the program, F9 to compile, and control F9 to execute. Okay, so suppose again I'm drawing the same triangle, enter number of vertices, but now I want to draw into the second quadrant. Values of x I just want to make it negative. So suppose I give minus 100 and 100. Y value I keep positive, okay, but the x value I just keeping negative. So it is again minus 200 and 100 B point, and again it is minus 150 and 150. So I'm drawing the triangle into the second quadrant. Okay, where the values of x is negative, y value I am keeping positive as it is. So my A point is minus 100, 100, minus 200, 100, minus 150, 150. Let us check how the object will look like. Yes, the object has or triangle has appeared into the second quadrant. Getting me? Now I want to move this triangle. Okay, now you can decide if you want to move into the which quadrant that you can move, or you can move into anywhere. Okay, now suppose I add this triangle. If it is having x value is negative, but now I just move into the translation factor x with 100. So I just want to move x value to be 100 and y value is 50, suppose. Okay, so I just check what value it will give me the result. Suppose I apply the translation factor tx is 100. In x direction I want to move by 100 and in y direction I want to move by 50. Okay, 150. Let us check how it will look like. So this is my original object. Okay, and I am moving it into the 100 point by x direction and 50 point by y direction. Yes, you can find the result on the screen. In x direction it has moved by 100 point and y means up direction. Okay, in up direction it has moved to the 50 point. So we can this is the generalized program where you can take any input as a if you want to draw rectangle, you can take the appropriate point and you can draw the rectangle also. Okay, and then you can move into the appropriate values. Okay, so this is what is expected. Okay, so in this program, okay, I just execute it one more time to show you that it is possible for us to draw the rectangle also. Okay, so any you can draw the line also because it depends upon number of vertices that you are giving as the input. Okay, and then you just apply the translation factor appropriately and you can find the original object with the white color and transform object is drawn with the yellow color just to differentiate between these objects. Okay, so you can just try doing this program. Okay, you can just execute, type the program into the C editor appropriately and you can execute this complete program. Okay, I just separated draw, original object and transform object so that in main function it will be more easy for me to just call the function. Okay, so this is the program that we are having for the 2D translation. Okay, so I just close the program, okay, of 2D translation and its explanation. Okay, I save the program, F2 to save and close the program. I hope all of you have enjoyed the C program execution of the 2D translation. Okay, so we have seen in detail how I can implement the concept of 2D translation with the help of the C program. Okay, and it is more easy and interesting to see that whatever we are learning theoretically, we can implement it with the help of practical, or using the C version, we can implement our concept. Okay, I hope all of you have enjoyed 2D translation. So we end the session here. Thank you all.